So welcome to our session today. I must apologize, I didn't manage to upload as we had agreed earlier. That was it was supposed to be done yesterday, but there are some issues on technicalities that did not allow us to do that. But we are going to start today, and I will take you through this one topic, the first topic, and I want us to talk about this statistics. Statistics 2. Remember that we already did statistics 1 in form 2. We already did statistics 1 in form 2. So this is what you will be required to note in this specific topic. So the first thing we are going to do is mean. And remember, in this case, we are doing mean using what we call assumed mean. That is the first thing we're going to do. The second thing we are going to do is median using something we call the organ. Number 3, we will now discuss in details the measures of dispersion. Measures of dispersion. And in this case, I will talk about standard deviation. I will also talk about variance. However, we shall start with variance followed by standard deviation, because this one is basically standard deviation is an extension of variance. So we will start with variance, then from there we know that we use the same formula with a little development to get the standard deviation. And lastly, we will still discuss this in details. In what we will be talking about, let us include that in the measures of dispersion. We will talk about quartiles, deciles, and percentiles. So this is basically what we shall be talking about. So the first thing we will talk about is mean using assumed mean. We will again find median using the ogive, and the other name for ogive, you might need to know that, is a cumulative frequency curve. Cumulative frequency curve. We write this one a little bit better. Curve. Cumulative frequency curve. So that is the other name for ogive, and we shall be getting median using that. And lastly, we shall talk about the measures of dispersion. In measures of dispersion, we'll talk about standard deviation, variance, quartiles and percentiles, deciles and percentiles. Although we'll still talk about this one will largely fall under the category of median, because we will be using the same formula for getting median to solve all this. So without wasting time, allow me to introduce the first one, called mean using assumed mean. So we shall be rubbing in more frequently, because my board is quite small, but I am sure it is going to help. So let's see. So the first one, mean using assumed mean. Now, one thing that is going to be very important in this topic, statistics 1 and statistics 2, is the formulas. So in this case, the first thing we will need to know is what is the formula for getting mean using assumed mean. Let us go back to mean in form 2. How are we getting mean in form 2? Mean in form 2 was gotten by summation of fx over the summation of f. So this is the first formula we did in Form 2. So you will need to recall that formula because in some cases, especially in paper 1, you will be told to find the mean using this formula, or basically just find the mean. So in that case, you will use this formula. Now in paper 2, which is what we are doing right now in statistics 2, you will be told to find a mean using assumed mean. So it will be very, very important to know the formula in that case. That is the first formula. So let's see, how do we get mean using assumed mean? So mean using assumed mean is gotten by A, which is the assumed mean, plus the summation of FD over the summation of F. So you will need to recall that A is basically the assumed mean, and D is the deviation from X. We'll see shortly what this one means. So we are basically saying that D is equals to the summation. We have just said that we erase that, just use it here. D is the deviation from X, the deviation from X. So in that case, we are going to take the assumed mean minus, X minus the assumed mean to get the value of D. X minus the value of A, the assumed mean. Please note that in most cases you will be given the assumed mean, the value of A. But there are instances whereby you will not be given. So when you're not given, you will be required, or you will be expected to get your own value of A, assumed mean. So you pick one of the values of X to be the assumed mean. You will see exactly what that one means. Now, this is basically what we need to know. In getting mean using assumed mean, So let us see how we are going to apply this formula in practice. How do we apply that formula in a case example? So I will let me capture some values here. So I will say I have mass, and here let me just call it frequency. So I pick the first one, 47, frequency 2. I pick 48, frequency 0. I pick the next one. After 48, I have 49, frequency 1. I pick another one, 50, frequency 2. I pick another one, 51, frequency 3, and lastly, maybe you can pick two more, 53, frequency 5, and lastly, maybe 54, give it frequency 6. So in this case, the mass is basically the value of X, because this is ungrouped data. I will also demonstrate how we use the same formula in the case whereby we are given grouped data. In this case, the data is ungrouped. So we've just said this is the formula, and you notice that frequency is the value of F. So and we are told, given that the assumed mean, so using 53 as the assumed mean. A, find the mean. So write this one properly, 53. So in that case, therefore, I will be required to get the value of we already have the value of A, we already have the value of F. What we don't have is the value of D. So I will need to bring in this D, and D is X minus A. Recall that. You will need to remember that. We've just said that the value of D is gotten by taking X, you subtract A. So the value of X is 47 and A is 53. A is 53. So let us get the values of D. So the first one is 47. X, because it's X minus A. Take note of that. X minus A. So X is 47, the mass. So 47 minus the assumed remain 53. So 47 minus 53 is obviously negative 6. Negative 6. Then we have 48 minus 53. That is going to give us negative 5. Then 49 minus that should give us negative 4. 50 minus 53, that gives us negative 3. And last is not noted there. 51 minus 53, negative 2. 53 minus 53, that is 0. 54 minus 53, that is 1. So we have the values of D. But notice that we've just said that the formula is the summation of FB, the summation of FB. So you will need to get the values of FB. And we erase that, FB. Now, notice that in this case, the frequency of each one of them, the first for 47 is 2. So we have 2 times negative 6. You get negative 12. 0 times negative 5. Is it 0 really? Yes, the frequency here is 0. 0 times negative 5 is 0. 1 times negative 4 is negative 4. 2 times negative 3 is a negative 6. 3 times negative 2 is negative 6. 5 times 0 is 0. 6 times 1 is 6. Then from there, the other assignment now is to get the summation of FD, because the formula reads A plus summation of FD over the summation of F. So in that case, you can now add all this, negative 12 plus 0 plus 4, that is a negative 16, negative 22, negative 28, negative 28 plus 6, that is negative 22. Then the summation of the frequency, summation of F, we have 2 plus 0, that is 2, 3, 5, 8, 13, 19. And in that case, therefore, your answer should be A, which is 53, plus negative 22, the summation of FD over the summation of F, which is 19. Then that should give you the answer. So make sure you do that to finality to get the correct value of that. And that is how you are supposed to get the mean using assumed mean. That is how you should get mean using assumed mean. So you can look at that and see exactly what we are talking about. So having mentioned that, I think we can now proceed on to something else, whereby now we consider grouped data. The approach is the same, only that you will be required to start by getting the value of X. So let's see exactly what happens in the case of grouped data. But notice that in that case, the formula will still be the same. Mean using assumed mean. You will use the same formula. So let me capture some values here. That is the table. So in this case, we are not talking about grouped data, but still getting the mean. So I have max and frequency. So my first class is 102, 103. My next class is, and the frequency of that class is 1. The next one is 104, 107, and its frequency is 15. My next class is 108, 2, 111, and my frequency there is 42. My next class is 112, 2, 115, and my frequency there is 31. And lastly, not yet there, second last, we have 116 to 119. And the frequency there is 8. And lastly, I have 120 to 123, whose frequency is 3. So, and just but to remind us, the mean using assumed mean is A plus the summation of FD over the summation of F. So already I will give you the assumed mean, but before that you will need to know how do you get D. We said that D is given by X minus A. Recall that. So do you have X? So notice that in this case we don't have X because we are given grouped data. We have classes 100 to 103, 104 to 107, 108 to 111, 112 to 115, etc. So you need to start by getting X. Recall that in Form 2, we said X is basically the midpoint. Midpoint. So midpoint, X. So just but to mention, maybe some of us have forgotten, how are we getting the midpoint? So let's say you have a class of 100 to 103. How do you get the midpoint? It's 100 plus 103 divided by 2. 100 plus 103 divided by 2. So let me capture the midpoints. For the first class, I'm going to get 101.5. We'll do the same thing for all of them. 104 plus 107 divided by 2. So the next class, 105.5. The next one is 109.5. The next one is 113.5 and 117.5. A difference of 4. The next one is 121.5. Notice that the difference is basically the class interval. The class interval of 100 to 103 is 4. It is not 3. It is 4. You count from 100 to 103. You count from 100 to 103. That is 100. 101, 102, and 103. That is 4. That is a class interval. Now you having the values of X, you can now get the values of D. D is equals to X minus A. Notice that I have not given the assumed mean, so I want to give the assumed mean. So in this case, I tell you using an assumed mean of say 109.5. So I have given you the assumed mean. I am giving the assumed mean of 109.5. That is my assumed mean, 109.5. But before we even proceed, let me just mention this. I said, in the event that I give you a question, then I do not give the assumed mean. You pick any of the values of X to be the assumed mean. Any of these values, we will all get the same answer. So if I don't give the assumed mean, you can take 105.5 as the assumed mean, 117.5 as the assumed mean, etc. Any of these values can be the assumed mean. You take any of these values to be the assumed mean. So let me get the values of D, X minus A. That is 101.5 minus 109.5. And my first value is negative 8. 105 minus 109.5, that should give me negative 4. 109 minus 109.5, that will give us 0. 113 minus 109, that should give us 4. 117.5 minus 109.5, that should give us 8. And 121.5 minus 109.5, that should give us 12. Yes, 12. Then from there, just check out the formula. The formula reads summation of FD. Summation of FD. So you will need to get FD. FD, that is the frequency times the deviation, D, x minus A. So 1 frequency times -8. Get -8. The next one is 15 times -4, that should be -60. I have the next one, 42 times 0, that should give us 0. Then I have 31 times 4, that should give us 124. I have 8 times 8, that should give us 64. And I have 3 times 12, that should give us 36. Summation of FD. So you add -8 plus -60, -24, 64, 36. That should give us a sum of 156. 156. And the summation of F is also very important. Summation of F, the frequency, the total frequency should be 100. And now you cannot replace in the formula. The summation of all these is 100. You have the summation of FD, which is 156. And you have the formula here. So assumed mean 109.5 plus summation of FD 156 divided by 100. That should give us the answer, which is 111.06. And that is how you get the mean using assumed mean in the case of grouped data. That is all about mean using assumed mean. Mean using assumed mean. So you can have grouped data and ungrouped data. In the case of grouped data, the only assignment that you are required to do is to get the values of x, which is what we have done here. After getting that, everything else is the same as what we did in the case of grouped data, as you have seen. So that is basically what we need to know in this case of mean using assumed mean. You can also look at that before we proceed on to something else. So allow me now to proceed on to something else. And in this case, I'll talk about quartiles. Deciles and percentiles. So these are the three that I want us to talk about now before we proceed on to the cumulative frequency curve. This is very, very important also. Now, something that will be very important in this area is the formula for getting median. In fact, the first thing we will need to get is the median. So, let me remind us the median formula. I want to remind us the median formula. And we did this in Form 2, whereby we said median is given by L plus N over 2 minus CF, it should be in brackets, divided by F multiplied by I, which is the class interval. Maybe I can just briefly indicate what it all then stands for. So let me write them here. L is the lower class limit. Then I have N is the total frequency. N is the total frequency. I have a CF, that is the cumulative frequency of the median class. What else? I have F, that is straightforward. It is the frequency again of the median class. Basically, everything we are talking about here is that of the median class. We still have I, which is again class interval of median class. So that is what each one of them stands for. In that formula, you might need to know that. That is still very, very important. You must remember that, what each one of them stands for. Now, before we proceed on that, I want to capture a table here, or data, group data also again. So I have height in centimeters. And definitely the frequency. So height, the first class is quite a number. I have 145, 2, 149. The next class, 150 to 154. My next class is 155 to 159. Have 160, 164. I have 170, 174, and lastly 175, 179. Let me name the frequency of each one of them. This is 25, 16, 9, 5, 2, and 1. So, having captured this, one thing you will notice that is very, very prominent in this formula is the CF. CF is very, very significant in these three areas: quartiles, deciles, and percentiles, and obviously median. This CF is very, very important. So the first thing you will need to get, even within this in Form 2, for you to get a median, the first thing you must get is the CF. CF is very, very important. So CF, can you see? So CF 2, 7, 23, 32, 37, 39, 40. That is the cumulative frequency, and indeed, when you add this summation of F, you should get 40. So I am sure you have already captured this. If you have not, you can always play back and capture this information here, because I want to erase that, you can solve some of them. So let's say you want to get the median. So for us to get the median, we must first of all get the median class. So how do we get the median class? Take n over 2. So 40 over 2 gives us 20. So we want to locate in the cumulative frequency column where 20 is. So we have, this is 27, 23. That means 20 is accommodated here. And that means we already have our median class. So our median class is 155 to 159. So to get the median, you just substitute in the formula. L is the lower class limit of the median class, and obviously, as we all know, the lower class limit of this class will be 154.5 plus, so open the brackets, n over 2, n the total frequency 40 over 2 minus CF. Now take note, CF is the cumulative frequency above the median class. I hope you will agree at that. CF, cumulative frequency above the median class. So above the median class, that is 7, so minus 7, over F. F again is the frequency of the median class, and the median class is 155 to 159, and its frequency is 16. So divide by 16, and I multiplied by I, which is the class interval. Remember, say the class interval is 155 to 159. So in this case, you count from 155 to 159, which gives you a class interval of 5. When you simplify this, you should get 154.5 plus this is 20 minus 7, that is 13 over 16 times 5. And that should give you the answer. So I think from there you should be able to get the correct value, and the median in that case you should get as 158.75. Sorry, 1.7. And you solve that, you should get 158.7. In case of any challenge, you can always tell me if this answer is not accurate or you're getting a different answer. You can ask in the comment section so that we can figure out whether we captured the correct value there, or you are the one who has a challenge in getting the correct value, So that is how you get the median. Now, how about these ones? Quartiles, deciles, and percentiles. Now these ones is typically the same as how you're getting the median. However, maybe let me capture that. We have quartiles. So in quartiles, you will be required, or rather, we are going to group them into two, whereby I'm going to have the lower quartile and number 2 upper quartile. So, and this one is denoted as Q1, and this one is denoted as Q3. So lower quartile is Q1, upper quartile is Q3. Now, how do we get the lower quartile? Q1. The first thing, in lower quartile, remember in the case of median, we were taking n divided by 2, basically a half of the total frequency. In this case, in getting the lower quartile, I'm going to take a quarter of the total frequency. 10, so basically 10. So, come back to the cumulative frequency column, identify where 10 is located. Notice that this is 7, 10 must be here. So again, this is our class of interest. So say a quarter of 40, get 10. 10, check in the cumulative frequency column where we have 10. This is 7, so we are not yet at 10. So you will need to use this class also because 10 is located here. So this is our class. So let me capture that. 155, 159. So again, replacing the formula. Lower class limit, 154, minus. CF is the cumulative frequency above. Again, 7. We should get 155.4375. That is the lower quarter. That is Q1. How about Q3? I not intend to erase that so that we are able to compare the two. So let me capture Q3 here. Q3, in Q1 we've done a quarter of the total frequency. In Q3 we take 3 over, Q1 1 over, Q3 3 over 4. Quartile, 3 quarters, 3 over 4 times 40. Get by 4 1 by 4, 10, so I have 30. So my frequency is 30. So cumulative frequency column, identify where we have that. So 30, this is 23, 32, so 30 is here. So our subject or class of interest is 160 to 164. 160 to 164. Having identified that, it becomes easy to just replace the same way we've done here. So lower class limit is 159.5 plus, here in this case it's 3 over 4, not 1 over 4. So 3 over 4 is 40 minus CF, cumulative frequency above. This is our class of interest here. CF 32. Frequency CF above. CF above 23. Over the frequency of that class is 9. Then multiply by the interval 5. And that is basically what you need to know. By 4, 1 by 4, 10. 3 times 10 is 30. 30 minus 23 is 7. So I have 159.5 plus 7 over 9 times 5. And your answer should be upper quartile. That should give us a value of 163. 163 point 3889. So that is basically how you can get the upper quartile and the lower quartile respectively. Upper quartile, lower quartile. Let me erase this and mention something. So the other thing that you will be required to get is the deciles. So in the case of deciles, our point of reference is 10. So if I tell you to find the first decile, I am basically telling you to get that of 1 over 10. First decile. Second decile. In that case, you're finding 2 over 10. So let's see what that decile is 3 over 10, fifth decile is 5 over 10, seventh decile is 7 over 10, ninth decile is 9 over 10, etc. But obviously you can only go as far as 9 decile because 28 is located here. Our class of interest in that case is 160, 164. And the lower class limit again, you will use the same formula. That is why I say the formula here is very, very important. You now use the same formula. 159 lower class limit 0.5 plus 7 over 10 of 40. 7 over 10 of 40 minus CF, cumulative frequency above is 23, over the frequency of that class, which is 9. Then multiply by the interval 5. So in that case, we have 159.5 plus 10, that is 28. 28 minus 23, that gives us 5 over 9 times 5 times 5. Then from there, you should be able to do that. That is 159.5 plus 25 over 9. Then you should be able to solve that. That is basically what happens in the case of deciles. decimals. How about, or maybe look at that before I discuss the last one. That is deciles. You do the same thing if you're given any value. Come on, is 6th decile. 6th decile. You just replace here. We have 6 over 10. You'll have 24. 24 again, same class. Maybe talk about third. 3 over 10. So 3. This will give us 12. So 12 is located here. So your class now changes. You use 154.5 and everything else. So this one will also change. This one will change. This one will remain the same because all of them have an interval of 5. So that is basically what happens in the case of deciles. In the case of deciles. So with that, I think that is clear with all of us. Allow me now to proceed on to the last one. Which is percentiles. Now, in percentiles, it is the same thing that we've just done all through, only that in this case, percentiles derived from the name percentage. Percent, it's out of 100. So I'm giving an example of find the 80th percentile. 80th percentile. So 80th percentile, that is 80 over 100. So 80 over 100 times the total frequency, 40. I have 0, 0, 0. So I have 32. So let's see. After getting 32, you come back to the cumulative frequency column. Identify where is 32 located. This one is exact. We have exactly 32. That means it is in this class, the corresponding class, 160 to 164. So the class is 160 to 164. Again, same approach. Lower class limit, 159.5 plus, open the brackets, 80th percentile, that is the 80 over 100, times total frequency 40, minus cumulative frequency above, so that is 23, over the frequency of that class, which is 9, multiplied by the interval 5. We already know 80 over 100 of 40 is 32. So that should be easy. So I have 159.5 plus 32 minus 23. And that should be, this is a 32, yes. 32 minus 23. Yeah, that is a 19. 9, sorry. 9 times 5 over 9. And the answer should be 164. 164.5. Because these two will cancel out. So 32 minus 23 is 9. 9 over 9 times 5, the class interval. The class interval. To give us 5. So 159.5 plus 5, 164.5. And that is basically what you are required to do in the case of quartiles, deciles, and percentiles. Please note that you can be asked any percentile, 20th percentile, 80th percentile, 70th percentile, etc. So for example, if you were given, maybe we can do away with this one. I am told to find, instead of 80th, I am told to find the 60th. Or let me use 40. So 40 over 100 times 40. This gives us 16. So after getting the frequency of 16, just identify where is 16 located. Notice that 7, 16, 16 is here. So your class in that case will change. 155, 159. So the lower class limit will be 154.5 plus 40th. So it's 40 over 100 times 40 minus the CF above. CF above is 7. Divide by frequency of that class, in that case is 16, times the interval 5, which is 5 for all of them. So here we have 154.5 plus, this is 16 minus 7 over 16 times 9. Again, this will give us, I think, 9. So we have 154.5 plus 9 over 16 times 9. Then from there you should be able to solve that and get the correct answer. So that is basically what happens in this case. The quartiles, deciles, and percentiles. So you can make sure you capture all those workings, the formulas, and you can do extra. Maybe in the case you're told to find deciles. I did 7th decile. You can pick any for the decile. So it's 4 over 10 times the total frequency, then proceed as we've just done. 9 over 10, proceed as we've done. That is the 9th decile. In percentile, you can pick 80th, we have 80th, we've done 40th, you can pick any. 20th, 60th, 75th percentile, 75th, that is 75 over 100 and the total frequency. You can pick any and get the correct answers. So that is basically what happens in this case. In quartile, deciles, and percentiles. So before we proceed on to something else, I want to discuss again quartiles in the case of ungrouped data. So we've done grouped. Let's see what happens in ungrouped. So for ungrouped data, so let me pick these values. I have 5, 10, 6, 5, 8, 7, 3, 2, 7, 8, and 9. They should be 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Correct? They should be 11. So, this is something we did in Form 2. The first thing, what we did is median. So for you to get the median, we say the first thing that you must do is to arrange these numbers in ascending order. You must start by arranging. If you don't arrange, if you start cancelling them without arranging them in ascending order, then you are not going to score. So in this case, I must start by arranging them. So in ascending order or in descending, in any order, but they must be in order. Let me arrange them in ascending order, starting with 2. The least value 3. I have 5 Nimbili, so you must repeat them. I have 6, 7 Nimbili here, 7, 7. 8 Nimbili, they are also true. 9, and lastly 10. Then from there you should be able to now find the median. So like you did in Form 2, you are cancelling them out. So I have 3 cancelling out with 9, 5, 8, 5, 5. I have 6 and 7. So our median value is that 7. So notice that this 7 will divide this data into 2 parts. We have the first part here, the other part on the other side. The first part we have 5 numbers, the second part we have 5 numbers, because in total they are 11. In total they are 11. So the median is 7. Now, how do we get 1? the lower quartile. Please remember, I say lower quartile is denoted as Q1. So when I write Q1, I am basically talking about the lower quartile, Q1. So in the case of ungrouped data, you start by you arrange them in ascending order. So if I give you ungrouped data, then I tell you to find the upper quartile or the lower quartile, then I expect you to start by getting the median. Why is the median important? Because it is going to divide the data into two equal parts. So in such a case, I'll always give you even number of entries, not even but odd number of entries, 11, 13, 17, 9, 7, etc. So divide it into equal parts. So start by getting the median. That is why getting the median was important. Now after getting the median, Q1 is the median of the first half. Notice that the first half is here. 2, 3, 5, 5, 6. 1, 2, 3, 4, 5. They are 5. The other half, 1, 2, 3, 4, 5. Then 7 divides them into two equal parts. So Q1 is the median of the first half. The first half is here on this side. So the median, you already know how to get a median. Just cancel them out. 2 cancels out with 6. 3 cancels out with 5. So the median for the first half is 5. And in that case, my Q1 is 5. Q3 is the median of the second half. So I have 7 cancelling out with 10. 8 cancelling out with 9. So I'm left with 8. In that case, here I'm left with 5. So Q3 is the median of the second half. And in this case, I've got the answer as 8. So that is how you find lower quartile and the upper quartile in the case of ungrouped data. So if I give you ungrouped data, that is how I expect you to find the lower quartile and the upper quartile. I repeat, step number 1, find the median of the set of data. That will help us divide the data into two equal parts. After dividing into two equal parts, now find the median of the first half. That gives us Q1. Find the median of the second half. That gives us Q2. And that way you have the solution for the two. Now, some two terminologies which are going to be very, very important with respect to quartiles. So you will be asked, let me give one, then I'll give the other one later. Just mention the two. We have interquartile range. So in the case of interquartile range, it is basically the difference between the upper quartile and the lower quartile. So this is given by Q3 minus Q1. Like in this case, I have Q3 as 8. So the answer here is 8 minus 5. So the answer is 3. Interquartile range. Then I have another term which is important here, semi-interquartile. Semi-interquartile is the same as what we talk about in football, semis. So semis, we are basically eliminating to be left with only the teams who are going to proceed on to the finals, which are only going to be 2. So in that case, semi-finals, in that case 2, that means you divide by 2. So that is Q3 minus Q1 over 2. So I have 8 minus 5 over 3. Over 2. So my answer here is 1.5. That is the difference. Semi-interquartile, you divide by 2. Interquartile, you just subtract. Please note that this is the same as in grouped data. Look, in grouped data, in the previous example that we did, make sure you're not lost. In the previous example, you can play back and see what we got, but these were my answers, Q1 and Q3. So Q1, in that case, I got the answer as, we check that, 155 points. 4375. Then for upper quartile, I got the answers 163.8889. Sorry, this is 38. So having the upper quartile and the lower quartile, you might be asked to answer these questions. Interquartile range, semi-interquartile range, the same thing. So interquartile range, you just take 163 points minus 155 points. Get the answer. That is interquartile range. 163.3889 minus 155.4375. Now in semi-interquartile range, semi-interquartile range, you will do the same thing but divide by 2. So it is the interquartile range over 2. Basically, the answer you get here, divide by 2. That is how you get the semi-interquartile range. But remember, in most cases, these questions are not developed from each other. So I'll just give you a question straight to find the semi-interquartile range. Semi-interquartile range. So I'll expect you to find the upper quartile, the lower quartile, then subtract the 2, then you divide by 2. So I'll give you find semi-interquartile range, 4 marks. So find the lower, find the upper, subtract, then divide by 2. So I'll expect you to do all this to get the 4 marks. So make sure you master that. That is the interquartile range and the semi-interquartile range. And that is all about quartiles, deciles, and percentiles. And look at that before we proceed on to another area of the measures of dispersion. Now, the last part, not the second last part, measures of dispersion. So this one is basically used to measure how much a set of data has deviated from the given or from the mean, from the average value. Measures of dispersion. Now, how many are they? So I will be discussing one. I have variance, and 2 standard deviation. Standard deviation. Or let me just mention this briefly. This will also be very important. We talk about 1, mean absolute deviation. 2, now talk about variance. And 3, standard deviation. Let me do them in that order to make it easy for all of us. Standard deviation. So these are the 3 measures of dispersion we shall be talking about. And I am going to use an example to discuss each one of them. But it is not something that is very, very important. It is a formula. So let me capture the table here. So I have length, and frequency. One 61, 162, 166. We have 167 to 171, 172 to 176, 177 to 181. So the frequency here, 12, 14, 24, 15, 8, 7. So you will allow me to do away with this. I'll just capture each one of them one at a time. So one thing that is going to be very important here is, remember, you can't be given the assumed mean to get the deviation, because that is something that is going to be very, very important here. So D, which is x minus a, the assumed mean. Now, remember I said, in the event that you're not given the value of D, you just pick any of the values of x. But notice that in this case, I still don't have the values of x. So maybe I should start with the values of x, which is the midpoint, basically. X, and then now D, which is x minus a. So in this case, I am giving you the assumed mean as 169. The assumed mean is 169. So let's get the midpoint first. The first one is 154, 159, 164, 169. So it comes to 5, right? 174. And lastly 179. And the assumed mean is 169. So let's get the values of D. So 154 minus 169 is negative 15. 159 minus 169 is negative 10. 164 minus 169 is negative 5. 169, 169 is 0. 174, 179 is positive 5. And lastly, 179, 169 is positive 10. So, in getting the first part, which is let me capture that. That is the mean absolute deviation. Now you will recall that we said absolute in maths means you ignore the negative value. You ignore the negative value. So in this case, I expect you to find FD absolute. The symbol for absolute is two straight lines, just as the same way you will denote magnitude. That denotes the size, the deviation from the average value, the deviation. So you ignore the negative sign because that basically indicates how many units that has been deviated, or it has deviated from the average value. That is why we are ignoring the negative value. So you find the values of FD, whereby we have the first one, which is 12. The frequency is 12, and the deviation is 15. So that is, let me see, the frequency for that class is 12. So we just multiply, and we start with these ones. This is 12. We don't have a calculator. 15. That should give us 10. 6. 2. That should give us 180. So absolute. So you ignore the negative sign. So you will have positive 180. This one you'll have positive 140. Here 24.5. That is 20. That again is 120. This will be 0. This will be 40. And that will be 70. Then you add the summation of FD absolute. That is going to give us 320. This is for 40, for 80, and 550. And we have the summation of F, and we check whether we have the total frequency, 80. This should be 80. So when you're told to find the mean absolute deviation, you'll take 550. That is the summation of FD absolute over the summation of F. That is the mean absolute deviation. Let me indicate this one a little bit clearer. Summation of FD absolute. So that means you ignore the negative signs. So as you multiply, you're multiplying 12 times positive 15. You are ignoring the negative sign in D, absolute D. So 12 times 15, 180. Then we do the same thing for all of them. So I'm going to have 550 divided by 80. That should give you the answer for mean absolute deviation. You ignore the negative sign. That is what we need to know. But now, and in that case, therefore, that takes us to the next level, which is number 2, variance. Variance. How do we get variance? The formula for getting variance is a summation of FD squared over the summation of F minus the summation of FD over the summation of F. You close the brackets, you square all of it. Summation of FD squared over the summation of F minus the summation of FD squared sorry, minus summation of FD over the summation of F, close the brackets, then you square the whole of it. So from there, then you should be able to look at the table and identify what we already have and what we don't have. Now notice that variance is meant to heal the assumption that we are doing in our previous case. In this case, we are ignoring the negative sign. In this case, in the case of variance, we've done this already. If you have a negative sign, how do you eliminate the negative sign? By squaring the value. So if you have negative 15, you square that, you get a positive value. You get a positive value. So in this case, I will start by getting, so just look at the table. Like I said, in this topic, one thing that is very, very important is the formula. So I need d squared. I already have, here in the case of FD, you can easily do that. FD, so it's F times D. So it's all this, only that we take care of the signs. So 12 times negative 15 is negative 180. 14 times negative 10 is negative 140. Here, this will be negative 120. These will still be 0. The next one will be 320. And lastly, that will be 400. No. This is a mistake. This should be 40. And this should be 70. Here is the summation of FD without now eliminating the negative sign. So we are not considering the absolute values. So this is negative 320, negative 420, plus 40, negative 420 plus 40, that is negative 380, negative 380 plus 70, that is negative 310. Write it here, but we have enough space. Then in the last, in the other case, we have FD squared. So I need the summation of FD squared. So I'll FD squared. This means that one, you start by getting the square of D, then multiply by F. D squared times F, D squared times F. So here we have 225. Next. Let me start by getting D squared. That should be 15 squared, that is 225. Then the next one is negative 10, that is 100. This is 25. This is still 0. This is 25. And we have 10, which is 100. So allow me to erase this formula. Then you capture it here. Variance is equal to summation of FD squared over the summation of F minus the summation of FD over the summation of F, close the brackets, square. So the next column from the formula, notice that you now need FD squared. You will need FD squared. So in this case, I am now multiplying the frequency times D squared. Frequency times D squared. Maybe we can start with these ones. 14 times 100, that is 1,400. I have we have over 15, that is 0. 25 times 8, that is 20. 16, 180, then 100, 1700. Then now add this. Now before adding, that is 14 or 14, 12 times 225 times 12, 5, 2, 2, 2, 4, 2, 5, 1. That is 25, 10. And then I have 25 times 24, 20, 10, that is 600. So having that, you can now add all this, and that should give us 2, 5, 10, 1400, 0, 1, 9, 3. Then you have 780, 0, 9, 16, 46, 90, and add 1700, 0, 9, 13, 6. So summation of FD squared is equals to 6390. Then from there you can now replace in the formula. I want to erase this one for mean absolute deviation again. We've done that. So I'm going to have summation of FD squared. It's here. 6390 over summation of F80 minus summation of FD negative 310 over summation of F80, then you square. Then that way you just get the answer. What happens in standard deviation? Because that is basically what you need to do in variance. You already have all that. That is what you're supposed to do. So in standard deviation, why I'm in a hurry to do this is because it's basically one and the same thing. So there is no confusion here. The only thing you need to do in standard deviation is to square root. So standard deviation is basically the square root of variance. So if you have variance, then you only get the standard deviation by finding the square root. So if you were to simplify that, you would write that a variance standard deviation is the square root of summation of FD squared over the summation of F minus the summation of FD over the summation of F squared. Please note, in most cases, I'll just give you straight, find the standard deviation. Find the standard deviation. So you should be able to do that. If you are told to find the standard deviation, you just find the variance, then find the square root. That is the standard deviation, square root of variance. So take note of all these. These are very, very important. And that is basically what you're supposed to do in getting variance, standard deviation, and mean absolute deviation. But mean absolute deviation, you just ignore the negative sign, find FD absolute here. Then add and use the formula. Summation of FD over the summation of F. That gives you the mean absolute deviation. Variance heals this idea of assuming by when squaring. When you square, that negative sign is eliminated. So take note of the formulas. One thing that is very important in this case is the formulas. The formulas are going to be very, very important. So make sure you can remember the formulas. So make sure you capture all this and do exactly how the way we've done it. Get the accurate values like in such a case. Get the answer and see whether you've understood how to find variance, standard deviation, and mean absolute deviation for grouped data. This is grouped data. So allow me to introduce the last part, which is the same thing, variance, standard deviation, only that in this case we are using ungrouped data. Let me use the example of the numbers that we had here. Let me pick another values. Number of children. That is value of x. And then number of families. The first entry 0, 1 to 6. 1, 2, 3, 4, 5, 6. The frequency 1, 5, 7, 10, 2. Now you're given the assumed mean is 3. Remember I said if you are not given the assumed mean, you can take any value. You can take any value on any of these values of x. These are grouped data. Now, before we even embark on the calculations, I want to make it very easy for all of us. I want us to recall the formula for getting variance was summation of fd squared over the summation of f minus the summation of fd over the summation of f squared. Now, this was for grouped data. So what happens in the case of ungrouped? So in the case of ungrouped, it's very easy. You just extract the first part of the formula. So variance for ungrouped is equal to the summation of fd squared over the summation of f. Notice how I have derived the formula. Take the formula for grouped data, extract the first part of the formula. That is how you get variance. And standard deviation, which is the square root of variance fd squared over the square root of f. So that is it. So before we even embark on substituting the formula, let us first of all get the values of d. Remember, a is 3, so let's get d, x minus a. Notice that we are repeating the same thing throughout the topic. So, x minus a, that is a 0 minus 3, that is negative 3, 1 minus 3, negative 2, 2 minus 3, negative 1, 3 minus 3, 0, 4, 1, 5, 2, 6, 3. Then from there, it's remember we've just identified that the formula for variance in this case is summation of fd squared over the summation of f. So I need to get d squared, but maybe I need to get d squared. Maybe before that, you need to recall we still have mean absolute deviation. It is important that we mention that mean absolute deviation. However, in this case, it's still the same thing. You just ignore the negative sign. So you just find FD absolute in the case of mean absolute deviation. So it's the frequency. So the frequency 1 times -3 is, sorry, in this case you ignore the negative sign. So that will be 3, 5, 2, positive 10, 11, 1, 11, 0, 10, 8, 6. Then summation of FD absolute 3, 13, 24, 24, 34, 42, 48. So mean absolute deviation, summation of FD absolute over the summation of F. The number of families in this case should be 60. Summation of F is 60. So I have 48 FD absolute divided by 60. Just that. And now to variance. FD squared FD on the but notice in our formula it is the summation of FD squared over the summation of F, so you can still do that. FD squared directly because we don't need FD in the case of group data. That is only necessary when we are doing group data. This is ungrouped. So FD squared. So we need D squared multiplied by F. So 3 negative 3 squared. Instead of ignoring the negative sign in the case of variance, we just square. So 3 squared, 9 times 1 get 9. 10 squared, sorry, 2 negative 2 squared, that is 4 times 5, that gives us 20. We have negative 1, that gives us 1 times 11 is 11. 0 squared times 27, that means with 0. 1 times 10. 2 squared, that is 4. 4 times 4 is 16. And lastly, we have 3 squared, 9. 9 times 2 is 18. Then the summation of FD squared. We're going to have 9, 29, 40, 50, 66, 84. So summation of FD squared is 84. So we have 84 divided by the summation of F, which is 60. And that gives us variance. For standard deviation, SD, it is the square root of variance. So it is the square root of 84 over 60. That gives you the standard deviation. That gives you the standard deviation. And that is basically what we need to know in that case. That is what we need to know in that case. In the case of measures of dispersion, but mean absolute deviation, variance, and standard deviation. Remember, standard deviation is the square root of variance. Variance yields mean absolute deviation. How does it do that? In mean absolute deviation, we ignore the negative sign. We have D, -3. So in FD, in getting mean absolute deviation, instead of working with the -3, we ignore, we take the absolute value 3. So 3, we have positive 3 multiplied by 3. Negative 2, you take the positive 2 multiplied by 5, you get positive 10. So in this case, we are ignoring the negative sign. So we heal that by introducing variance, which heals mean absolute deviation by squaring the values of d, deviation x minus a. Negative 3, to get the absolute variance, we square that. This is in ungrouped data. Negative 3 squared, you get positive 9. Now multiply by 1, the frequency f. Number of families is the frequency. So 1. 9 times 1 is 9. Negative 2 squared, you get 4. 4 times 5, 20, etc. Then now get the summation of fd squared to get 84. Now 84 divided by 60 to get variance. So this gives us variance. Then to get the standard deviation is the square root of variance. So it is the square root of 84 over 60. That is it. That is what you need to know in that case. So you can look at that before I discuss the last part of this chapter, which is cumulative frequency curve. How do we draw it and how do we use it? So this is the last part of this topic, cumulative frequency curve, which is also called orbit. So I want to see how do we draw that and how do we use it? Which questions can we answer using the cumulative frequency curve or the object? So let me capture a table here. I have a table of max. First class is 1 to 10, the next one is 11 to 20, the next one is 21 to 30, and the next one is 31 to 40, the next one is 41 to 50, the next one is 51 to 60, the next one is 61 to 70, and the next one is 91 to 80, 81 and lastly 91 to 100. The frequency for the first one is at 4. 9, 16, 24, 18, 12, 8, 5, 3, 1. Now, from even the name itself, cumulative frequency curve, cumulative frequency. That means you will need the column of cumulative frequency. me just call it CF. CF for cumulative frequency. Cumulative frequency. So the first one will be we have 4 plus 9, 13. We have 13 plus 16, 29. 29 plus 24, that is 53. 53 plus 18, that should give us 71. 71 plus that's 12, 83. 83, 91, 96, 99, and 100. Now, in drawing a cumulative frequency curve, we are going to draw, take note of that, because many students confuse at times. So, in drawing a cumulative frequency curve, you will draw along the y-axis, you will have the CF. Then along the x-axis, like in this case, we are talking about max. So, x-axis just label max. And you notice that we have all the way up to 100 cumulative frequency. So I can use intervals of 10, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, correct? 20, 30, 40, 50, 60, 70, 80, 90, and 100. 100. That is obviously the y-axis. This is the x-axis. Now in the x-axis, we use the class limits. So the first class is 1 to 10. The first one, just like in the histogram, the first one is the lower class limit. The rest are the upper class limits. So the first one is 1 to 10. So the lower class limit. Let's start from the origin, 0.5. I take an E10. Again. So 0.5 upper class limit, 10.5, 20.5, 30.5, 40.5, 50.5, 60.5, 70.5, 80.5, 90.5, and lastly 100.5. Then from there, we just plot the first one, the first frequency, and I want you to pay attention to this. The first frequency, 0.5, its frequency must always be 0. Its frequency must be 0. So for the first one, 0.5, its frequency is 0. Please do not use 4. 4 is for the next one. The first one, the frequency is 0. Take note of that. So I'll give this frequency 0. We plot there. So the next one, 10.5, I now give you the frequency 4. So 4 is somewhere here. The next one, 20.5, 13. Remember, we're using the cumulative frequency. 20.5, 13, somewhere there. 30, 29, somewhere there. 40, 53. 53, somewhere there. We have 50.5. 50.5 is 71, all the way to 71. I have the next one, that was the 71, that is 50.5. Now I have 60.5. 60.5 is frequency is 83. 83 slightly above this. And I have the next one, frequency 91. That is for 70.5. Frequency is 91, and 89 or 80.5. 80.5, the frequency is 96. And 90.5, the frequency is 99. And lastly, 100.5, the frequency is 100. Then after plotting, you can now join all of them. And remember, we agreed that you must always draw a very smooth curve. And notice that at all times the ogive or the cumulative frequency curve will always look like an elongated S. An elongated S. If you get anything which is not similar to what I have here, then that is not a cumulative frequency curve. Make sure you are able to draw such, and ensure that you draw a very smooth curve. And as I always encourage all of us, use dots when plotting, and ensure that you plot all the points and all of them are visible, and the curve occupies at least 3/4 of your paper, just like mine occupied at least 3/4 of the space that I had. And that is the cumulative frequency curve. Use the limits, the x-axis, but note the first one is the lower class limit, one lower class limit, the rest upper class limits. The y-axis, cumulative frequency, and that is why it's called a cumulative frequency curve. Another thing that is also very, very important is that as you plot the first point, 0.5, the lower class limit, the frequency of the lower class limit must always be 0. 0. Lazima kwe 0, you start at 0, the lower class limit of the first class. It must be 0. It must be 0. So I don't want to see a cumulative frequency curve which is running and start at this point. I will not encourage that. And again, make sure that you draw a very smooth curve, because you'll be required to answer questions using this. For example, 1, Q1, 2, Q3, and also 3, median. Let us start with median. Median, step number 1, we said you're getting half of the total frequency. So in this case, the total frequency for all these marks should be, I think, 100. Yes, we already have it there. Summation of F is 100. So to get a median, using the cumulative frequency curve, remember, you're not using the formula. You're using the cumulative frequency curve. So to get a median, half and 100, you get 50. Now you will not come back. You will not come back and identify the median class. No. Having the value 50, using a cumulative frequency curve, cumulative frequency 50, so you come to the cumulative frequency column, which is the y-axis, mark 50, so you've identified 50 is here. So using a ruler, you move along that line until you meet the curve. Then down along that line to the x-axis. So in that case, my median will be 40.5. That is how you find the median using the cumulative frequency curve. 50, move along that line using a ruler. So you draw this line, then draw this line. Where your line meets the x-axis, you read that value, 40.5. That is the median. How about Q1? Q1, tulisema it's a quarter of 100. That should give us 25. So where is 25? 25 is somewhere in between here. So 25, your ruler again, move along that line, then move along that line, you leave the value there. So Q1 should be 30.5. Q3, 3/4, that is upper quartile, 3/4 times 100, you get 75. So rotate 75 here. You read the value there. So Q3 again, you got 50.5. 50.5. Notice that you should be able to answer even the question on interquartile range using this curve. Interquartile range. Interquartile range, we said it's the upper quartile minus the lower quartile. So if I give you that, draw the cumulative frequency curve, then next find the interquartile range. So basically, I am telling you to use the cumulative frequency curve to find one, the upper quartile and the lower quartile, and I have just demonstrated 1 over 4 times 125. Come to the cumulative frequency 25, move along that line, you get 30.5. Then 3 over 4, you get 75. So if you are supposed to get the interquartile range, that should be Q3 minus Q1, which is 50.5 minus 13.5, and the answer is 20. Now Kiulizwa, if the question is semi-interquartile, so basically you do the same thing, only that you divide by 2. Only that you divide by 2. And that is what you need to know in how to get the lower quartile, the upper quartile, the median, using the cumulative frequency curve. You can still find all the others. The 7th decile. 7th decile is 7th decile using the curve still. That is 7 over 10 times the total frequency 100. So the answer there is 70. So again, cumulative frequency curve, find 70, it's here. Move along that line until you meet the curve. Then down along that line, you read the value here. You obviously, as you draw on a graph paper, you should be able to read that. Again, percentile, 80th percentile. 80 over 100 times 100. You get 80. So cumulative frequency, 80. Then you read the value. There, you read the corresponding value. That way you should be able to find the 80th percentile and 70th deciles, percentiles, and quartiles using the cumulative frequency curve. Make sure you remember how to draw that and draw a very smooth curve, a very smooth curve. Just by the way, let me mention this. You're told that if the pass mark is a set at, let me use 40.5, find the number of students who passed. So I'm told the pass mark is 40.5. The pass mark is 40.5. Remember, this is max. So pass mark, you may set pass mark at 40.5. I want to see how many students will pass. So if the pass mark is 40.5, if you want to know how many students passed the test, then you come all the way to 40.5, then move along that line, 40.5. Move along that line to that point until you make the curve, then move along that line. So in this case, you'll get this is 53. So 40.5 pass mark until you make the curve, then along that line. You'll find this is 53. The question is, find the number of students who passed. This is what I want you to know. From 0 to that mark is the number of students who failed. 0 to that mark, or from that mark to 0, these ones failed. From that mark to the maximum, those ones passed. So if we got 53, and the question wants us to find the number of students who passed. The total number of students is 100. 0 to 53 failed. So how many passed? It is the total 100 minus 53, which gives us 47. How about if you're told to find the number of students who failed? The number of students who failed, the answer is direct, 53. Because 53 to 0, those ones failed. 53 to maximum, passed. You can see as you move towards this side, in this direction, the marks increase. 90 marks increases. So if the pass mark is 40, when the go the other side, those ones passed. Beyond 40.5. Below 40.5, failed the test. Failed the test. So maybe I can add another one. How about if we are told now we reverse, find the pass mark. Find the pass mark. If 30 students, 30, if 9 students pass the test. So we are talking about 9 students passed the test. We are looking at a situation whereby the remaining fail, and remember they are saying from 0 to that mark fail, from that mark to the maximum pass. Now we are told find the pass mark if 9 students passed the test. So how many failed? So the first question you must ask yourself is how many failed? So if 9 passed out of 100, then fail 9 minus 100 minus 9, 91 fail. From 0 to 91 here, 91 fail. So 91 to 100 pass. So we use this to determine the pass mark. That is a 60.5. So the pass mark is 60.5. So note, we are basically saying that to get a pass mark, we use the number of students who failed. So to get the pass mark, we use the number of students who failed. The number of students who failed. Just but to repeat, fail is from 0 to that mark. So 9 passed, so 91 failed. 0 to 91 failed. 0 to 91 failed. 91 to 100 passed. 9 students. And with that, you should be able to respond to these questions as required. You can even get a question on a probability. You're told find the probability that a student scored or a student picked at random. Find the probability that a student picked at random scored between say 20.5 and 50.5. 20.5. So 20.5, we should have a 13. Then 50.5, we should have 50.5 go all the way to 71. So find the probability that a student picked at random scored between 20.5 and 60.5 marks. And we've just seen that for 20.5 you have 13, here you have 71. So how many students are in between here? To get the probability. Remember we said probability, or rather you should be aware that probability is the number of favorable outcomes. Probability, number of favorable outcomes over the total number of trials. So let's see, 20.5, 13, 60.5, 71. So how many students are there in between from 13 to 71? That is 71 minus 13. That should give us 8, 58 students. But the question is probability. So it's 58, so the number of favorable outcomes is 58. Over the total number of trials is, we are selecting a student from how many? From a total of 100. So that is 58 over 100. You can simplify that or just leave it as such to get 29 over 50, or just leave it as 58 over 100. 29 over 50. That is the probability that a student picked at random will score mark between 10.5 and 60.5. And with that, you should be able to answer any question dealing with the statistics. In case there is any part that you have not understood, leave us a question in the comment section. I will answer, or any other person who has understood will answer that question. And I will attach the notes for this particular video alongside the same video. You should be able to see that. I will also attach several questions which you're going to do to practice on whether you have understood this particular topic. And don't forget to use your Simuturi to answer all the questions in statistics. In fact, I want to encourage you that today and tomorrow and maybe the next day, go through this video as many times as you can or as you want. Do the practice questions I have sent you, and don't forget to do all the questions in your Simuturi, because with that you should be able to score. And not forgetting to go through the questions in our main familia. That is also very, very important. And with that, I want to thank you for waiting, because I failed yesterday, but I am sure you got the message on why we need to wait until today. And for today, you should be able to get this information. Please do that. Go through it. Encourage those of us who have not yet subscribed to join us and go through this work together, so that later we should be able to do something else when we resume. With that, I want to thank you until we meet the next day or the next day, but make sure, or the day after, just ensure that you do this. Thank you, and have a nice time at home.